Unit 7. So this is classwork 7.1, Introduction to Quadratic Functions. In previous chapters, you have investigated linear equations. In Unit 7, you will study quadratic functions. You'll learn all you can about their shape, study different equations used to graph them, and see how they can be used in real-life situations. So pretty much the rest of the semester is going to be devoted to quadratics. Units 7, 8, and 9 are all quadratic units. And then we'll have one Unit 10 after that, and you guys are done for the semester. So it's really important to make sure that you know what's going on with these quadratics, because if you start getting lost early on, you're going to be lost for the next 3 chapters. So make sure that you seek help or ask questions if you need it. Question number 1, examine the tile pattern at the right. After everyone has had a moment on his or her own to examine the figures, discuss what you see with your team. And obviously when we're doing the videos, just see if you can see what's going on with these patterns. All right, so the first thing I see is 3 tiles that are never changing. Always got this one, that one, and that one. Always got these 3 here, and those are never changing. So I can guess that figure 5 is probably going to have 3 tiles. And also figure 0 is going to have those 3 tiles. Okay. Now the next thing I notice is that we've got some squares here. Here we've got, in figure 1, we've got 1 square. In figure 2, it's growing, but it's not growing by 1, it's growing by 3. But in figure 3, we're going from 4 to 9, so that's growing by 5. So that doesn't really make sense that this is growing by 3 and that's growing by 5. So we have to think of it a different way. Notice here we have a square. We've got a 1 tile by 1 tile square. Right there we have a 2 tile by 2 tile square. 2 by 2 in figure 2. In figure 3, it's growing even more, and now we've got a square that is 3 tiles by 3 tiles. In figure 4, same thing holds true. So in figure 4, we've got 4 tiles by 4 tiles. So that means figure 5, we're going to have a big square here, and it's going to be 5 by 5. So it's a 5 by 5. How many tiles are actually in there? And to get that, we just multiply those 2 numbers. So 5 times 5 is 25. So we've got 25 tiles in that square. And if we go back to figure 0, if we've got figure 1 is a 1 by 1, figure 2 is a 2 by 2, figure 0 is going to be a 0 by 0 square. So there's not going to be any additional square there. It's just going to be those 3 bottom tiles. So let's put this information into the table. So figure 0 has 1, 2, 3 tiles. Figure 1 has 1, 2, 3, 4. Figure 2 has 2 times 2 is 4, 5, 6, 7. Figure 3, 3 times 3 is 9, 10, 11, 12. Figure 4 is 4 times 4, that's 16, 17, 18, 19. Figure 5 is 5 times 5, which is 25, plus the 3 is 28. Figure 6, any ideas what that would be? And if you can complete that, go ahead. Otherwise, we're going to take a look at the patterns here. So my figure number, how do I go from 0 to 1? Plus 1. How do I go from 1 to 2? Plus 1. So this is going to keep increasing by 1 each time. Let's take a look at my number of tiles. How do I go from 3 to 4? What am I adding to that? Adding 1. How do I go from 4 to 7? Add 3. How do I go from 7 to 12? I add 5. Continuing on, 12 to 19, I'm going to add 7. And hopefully you guys are seeing the pattern now. So 1, 3, 5, 7. I'm going to add 9. I'm going to add 11. I'm going to add 13. So 28 plus 11 is going to be 39. And 39 plus 13 is going to be 52. All right, so we finished the table. Question letter C, are the numbers of tiles increasing at a constant rate? So is this increasing by the same number every time? No. It is increasing, but not at a constant rate. So no, it is increasing, but not at a constant rate. Question D, what do you notice about the rate of change of the rate of change? This is also known as the second rate of change. And I know that's probably super confusing, the rate of change of the rate of change, but it actually makes sense. So if this is my rate of change, what is the rate of change of that? So if I look at how these numbers are increasing. So how do I go from 1 to 3? I add 2. How do I go from 3 to 5? I add 2. How do I go from 5 to 7? Add 2. And if you notice, every single time, we're adding 2. So, and once again, we're going to call this the second rate of change. From here on out, we'll call it the second rate of change. So what do we notice about the second rate of change? So there is a constant increase of 2 each time. You notice it's increasing, the second rate of change is increasing by 2 each time. This is something you'll notice about quadratics. The rate of change will not be consistent every time, but the second rate of change will always be the same with quadratics. That's one way that linear equations are different than quadratics. Question E, draw a sketch of figure 100. Determine how many tiles are in figure 100. Show how you arrived at your answer. All right, so in all of these figures, we all had the same purple 3 tiles. So let's draw those 3 tiles. So for figure 100, we're going to have those 3 purple tiles. And then we are also going to have a square. And it might be a little bit hard to tell how big that square is, but figure 1 was a 1 by 1, figure 2 was a 2 by 2, figure 3 was a 3 by 3, figure 4 was a 4 by 4. So figure 100 is going to be 100 by 100. And this is perfectly okay for how to write that. You don't need to try and draw the squares. Please don't try and draw 100 rows and 100 columns. That's completely unnecessary and not possible, and I will never count those. And then it does want us to determine how many tiles are in figure 100. So remember, when we have a square, you guys know how to find the area of the square. It's base times height, right? So we're going to do 100 times 100, and then we're going to add those 3 squares on at the end. 100 times 100 is going to be 10,000 plus 3. So we're going to have 10,003 tiles. Once again, please do not try drawing 10,000 tiles. X is going to be very similar. So for figure X, we're going to have the 3 purple tiles, and then we will have the square. And in this one, it's going to be X by X. So my general pattern will be X times X plus 3, which is then X squared plus 3. So remember, X times X is going to be X squared. So Y equals X squared plus 3. Question G will be in the next video.